Section 6-2 takes what you learned in Section 6-1 and applies it to some application problems. So what we'll do is we'll remember from 6.1 we were dealing with this normal curve, and the fact that the normal curve, depending on what our z-score was, could tell us area under the curve, which relates to probability. So what we don't want to do is we want to set it up in the context of this problem right here. It says this: an adult has on average 5.2 liters of blood. Assume the variable is normally distributed, which means we can use the normal model, and has a standard deviation of 0.3. So we have the important information of 5.2 is our mean and a standard deviation of 0.3. It says this: find the percentage of people who have less than 5.4 liters of blood in their system. So the average is 5.2. How many people have 5.4 liters or less of blood in their system? The way we answer that is through this normal curve and being able to then find percentage off of the normal curve tables that we used in the previous section. But in order to do that, the normal curve tables, you can see here, if you remember, operate off of z-scores, not off of data such as liters of blood. So what we need to do is we need to convert the important value, or the value under consideration, which in this case is the 5.4. We need to convert that into a z-score. So to do that, we remember that the z-score is equal to x minus mu over standard deviation. So in this case, our z is equal to 5.4 minus the average of 5.2 divided by our standard deviation of 0.3. So we're going to do 5.4 minus 5.2, whatever that is, divide that by 0.3. And I'm getting a z-score of 0.67, rounded to the nearest hundredth there. So 0.67. If I take a look at standard deviations 1, 2, 3, the z-score of 0.67 is somewhere around here. So I want to find the percentage, that is area under the curve, less than 5.4 liters, which correlates to a z-score of 0.67. So that's all of this area down here. So we need to go to our z-score table, our normal distribution table, and find 0.67. So back to this table, 0.67 for a z-score. It's going to have to go to this page. 0.67. 0.67 gives us 0.7486. 0.7486 is this area right here. So what percentage of people have less than 5.4 liters of blood? 74.86 people have less than 5.4 liters of blood in their system. And the key there is to relate that value of interest to a z-score so that we can then use the normal distribution tables to find the area. To solidify this, let's take a look at another example. So example number 2 says this: each month an American household generates an average of 28 pounds of newspaper for garbage or recycling. Assume the variable is approximately normally distributed, good, and that the standard deviation is 2 pounds. So we have a mean of 28 and a standard deviation of 2 pounds. If a household is selected at random, find the probability that it generates between 27 and 31 pounds per month. So we generate a normal curve, just like normal. In this case, our average is 28 and a standard deviation of 2, but the values of interest are 27 and 31. 27 is a little bit less than the 28, and 31 is more than the 28, the average. So this is the average of 28, and this is the 27 and the 31. So what I need to do is I need to find z-scores for each of these values so that I can then go to my table. So let's do the z-scores. Z is equal to x minus mu over standard deviation. So for our first one here, the 27, z is equal to 27 minus 28 all over 2. And 27 minus 28 is negative 1. Negative 1 over 2, that's just negative 0.5. We can do that one in our head. What about the next one, though? Next one here, we've got 31 minus 28 all over 2. 31 minus 28 is 3. 3 over 2 is 1.5. 3 halves is 1.5. So we have a z-score here of negative 0.5 and a z-score here of 1.5. We want to find the probability that it's between those two. So I need to find the area between those two z-scores. So let's start with a negative 0.5. So to our table, negative 0.5. Negative 0.5, and this first column is the 0 column. So negative 0.5 takes us here, 0.3085. So .3085. Go back and check that to make sure. 3085, yep. So 0.3085, but that's the area less than. So the 0.3085 is the area less than the 27, or the z-score of negative 0.5. But I want the area greater than that, but less than 31. So let's go ahead and find the area to the left of 1.5, a z-score of 1.5. 1.5 is right here. That's 9332. So 0.9332. But again, that's the area less than the 31. I want the area between. So if I take the area less than the 31 and subtract the area less than the 27, that leaves me this area in between. So I need to do 0.9332 minus 0.3085. 0.9332 minus 0.3085. And this produces 0.6247. So what's the probability that a randomly selected household generates between 27 and 31 pounds? There's a 62.47% chance that that household generates between those two values, which means there's about a 38% chance that they generate less than 27 or more than 31 if you're looking outside those limits. So that's how we take and apply what we learned about z-scores and the normal curve in 6.1 to an actual application problem. The connection is you have to be able to calculate z-scores for the values of interest.